Mirror, mirror on the wall, who's the most sadistic of them all? Why, me, of course. Because not only is this our last class of Unit 5, which is punishment in itself, because this unit has been so much fun, we're going out with a bang. You have yet another problem set to complete for me, which means that this video is optional. You do not need to watch it, nor do you need to take notes. However, as you're moving through your problem set, if you find yourself getting a little stuck and you want to see if this can help get you unstuck, here are a couple more examples worked out for you. At no point will I tell you to pause the video, but I would encourage you, as I keep working, to stop, try it on your own, compare your answers against mine. Let's get into it. First up, two angles of a triangle, angle x and angle y, are complementary, meaning that the sum of their two measures is equal to 90. The measure of angle y is also 6 less than twice the measure of angle x. We want to find the measures of each angle. So I don't particularly need a diagram here. It turns out I've got all the information that I need without my pretty picture. Let me start by defining my variables. Looking at my last sentence, I'm told that I need a variable to represent the measure of each angle. In a totally shocking turn of events that nobody saw coming, I'm going to choose the variable x to represent not angle x, but specifically the measure of the angle. And when I'm talking about measures of angles, I know that angles are typically measured in degrees. Same thing, unsurprisingly, I'm going to pick the variable y to keep track of the measure of angle y in degrees. From here, I now need to build my equations. Looking at my first sentence, I'm told that my two angles are complementary, which is a fancy geometry word of saying that the sum of their measures is 90. Well, the measure of angle x, we've defined as x. If I add that to y, which is the measure of angle y, that means I should get 90. I also know that the measure of angle y is 6 less than twice the measure of angle x. Reading left to right, the measure of angle y is y. Is gives me my equal sign. And then if I'm 6 less than twice the measure of angle s, well, twice the measure of angle x is 2x. 6 less than that would be 2x minus 6. We've now got a system of equations. You can solve this however you want. I personally notice I've got a y by itself. That's a great setup for doing some substitution. So by substitution in the top equation, I can now replace every y with the equivalent statement of 2x minus 6 from the bottom. Beginning by combining some like terms, x plus 2x is equal to 3x. 3x minus 6 is equal to 90, so let me add 6 to both sides to begin to isolate my variable. I have 3x is equal to 96. To get x by itself, all I need to do is divide both sides by 3. X is equal to 32. Knowing that x is 32, I now can substitute to find the value of y. I'm going to choose to substitute into the bottom equation. Notice that my goal is to get y by itself in the bottom equation. Y is already isolated. So by substitution, I can say that y is equal to 2 times 32, which is 64, minus 6 tells me that y is equal to 58. And if I'm being really good, that tells me in a complete sentence, I could say something like x, or angle x, has a measure of 32 degrees, and y, or angle y, has a measure of 58 degrees. Very nice. Let's go swimming. Mermaid Barbie challenges her pet dolphin to a race where both must swim up and down the length of a 12-mile-long river. Going upstream, it takes Mermaid Barbie 3 hours to traverse the river. She can complete the journey downstream, however, in only 2. What are Mermaid Barbie's swimming speed and the speed of the current? Again, I don't particularly need a diagram here. Let me start by defining my variables. I need 1 to keep track of Barbie's swimming speed, 1 to keep track of the speed of the current. So I'm going to pick the variable b to represent Barbie's swimming speed. Of course, here, we're traveling miles in our river, and we're doing it in some number of hours. So our unit is going to be miles per hour. Same logic here. I'm going to pick c to represent the speed of our current. in miles per hour. From here, I need to build my system. But before I can do that, this is a classic example of a travel problem. I've got some distance that I cover. I'm traveling at some speed. I do it in some amount of time, which means I need to use a formula to keep track of the relationships between all of the parts of my problem. That formula, of course, we've said it ad nauseum. If I want to find the distance that is traveled, well, that would be the product of the speed at which I travel and the amount of time for which I travel. And I have two cases here, one where Barbie is going up the river and one where Barbie is going down. So I'll say our top case is our up case and our bottom case is our down case or our downstream case. Let's start with the rates. When I'm going up the river, that means the river is flowing in the opposite direction from what I'm swimming. So if Barbie travels at b miles per hour and the current is pushing against her, it's going to subtract from her speed. So the total speed would be whatever Barbie's speed is minus the speed of the current. By the same logic, when we're going downstream, the current is going to make Barbie go faster. It's going to add to her speed. In both cases, filling in the rest of our table, it's a 12-mile long river. So the distance is going to be 12, both upstream and downstream. Last thing that I need to know is the amount of time. Well, we know that it takes 3 hours for Barbie to go up the river and 2 hours to go down. Using our formula, we can now build our system. So we know that distance, which is 12 in both cases, will be equal to the product of rate and time. So if in our upstream case, we take 3 and multiply it by the b minus c, and in the bottom case, we take our 2 and multiply it by our b plus c, both of these should give us our statements. From here, I'm going to choose to solve this system by elimination. You can absolutely do some substitution. I can multiply both equations by something to get a common coefficient. I can also divide, because division is the opposite of multiplication. Notice 12 is divisible by both 3 and 2. So I'm going to divide the top equation by that 3 and divide the bottom equation by that 2. Dividing the top equation by 3, 12 divided by 3 is equal to 4. And then I have 3 times b minus c divided by 3. Well, those 3's are going to undo each other. I'm just left with the b minus c. By the same logic, in the bottom, 12 divided by 2 is 6. On the right side, I have 2 times b plus c, but then I'm dividing by 2. The 2's undo each other, and I'm just left with b plus c. There's a nice system that we can solve by elimination. From here, I'm going to add the 2 together. You can do either one. It doesn't really matter. Adding 4 plus 6 is going to get me to 10. B plus b is going to get me to 2b. And then negative c plus c, those get me to 0. I have 10 is equal to 2b. To solve for b, I'll divide both sides by 2. Therefore, Barbie's speed is going to be 5 miles per hour. Now I just need to find the value of c. No right answer for where to substitute back in, but notice up above I've got 2 nice equations with some pretty nice coefficients for b and c. I'm going to pick the bottom one. So I know that 6 is equal to Barbie's speed, which is 5, plus the current speed, c. To get that c by itself, all I need to do is subtract 5 from both sides to find that the speed of the current should be 1 mile per hour. Lovely. Let's get personal, shall we? Mr. Volel is about 2 years older than his younger sibling, August. 10 years ago, as of the time of recording at least, I might be really old now, August's age was 6 more than half of Mr. Volel's age. How old are Mr. Volel and August now in the good old year 2026? Alrighty, let's get to it. I need to start by defining my variables. I know that I want to keep track of my age and my sibling's age. So I'm going to define the variable v to keep track of my age because my last name starts with a v. And then I'll use A to represent August's age. Now, if I'm thinking about how to build a system, this is actually another type of problem, sometimes called an age problem, or some people might call it a puzzle problem, where a table could be really helpful. Let me show you how a table could help me. I'm going to give myself, just like above, my two cases, and I'm going to give myself two columns. One where I can keep track of my stuff, and one where I can keep track of August's stuff. Well, my two cases, I have however old I am now, but I'm also being told something about this 10 years ago. So I'm going to make my two cases. Well, how old are we now? And how old would we have been 10 years ago? Well, right now, we've established I'm V years old, and August is A years old. 10 years ago, I would be 10 years less than V. So I would be V minus 10 years old 10 years ago, and August would be A minus 10, whatever their value of A is. From here, I now have everything that I need to build my system. For my first equation, I'm told that I am 2 years older than August. So from this, I could say that my age, V, is going to be equal to whatever August's age is, which is A, plus 2, right? I'm 2 more than them. And then I also have this 10 years ago case where I know that August's age was 6 more than half of mine. So August's age 10 years ago is A minus 10. So A minus 10, their age 10 years ago, would be 6 more than half of my age 10 years ago. Well, my age 10 years ago was V minus 10, and I want half of V minus 10, so I have 1/2 times V minus 10. You could also write V minus 10 over 2 divided by 2. And then I'm 6 more, or August was 6 more than that, so I need to add 6 to this number. There we go. There's our system. From here, I'm going to choose, again, I have a nice V by itself here. I'm going to choose to do some substitution. So in the bottom equation, every time that I see a V, I'm going to replace it with A plus 2. So we've got this new substituted equation. From here, let's simplify. So I've got 1/2. I'm going to distribute that 1/2 to each of the terms in my parentheses. So this would become A minus 10 is equal to half A plus 1 minus 5, and then I've got my plus 6 at the end. Combining all of these like terms on the right side, I have 1 minus 5, so that would be -4, plus 6, which is 2. So all of those numbers get me to plus 2. And now I need to get rid of my multiple variables. So I'm going to move all of my A's to the left side. You could also move them to the right side. That's a totally acceptable choice. A minus half of A. Well, if I take half of something away, I'm still left with half of it. So this should be 1/2 A minus 10 equals 2. To get that A by itself, let me add 10 to both sides. That tells me that half of A is equal to 12. And if I want to get rid of half, well, I should multiply by 2. 2 times 1/2 gives me 1. So A is equal to 24. That tells me that right now, August is 24 years old. But I also need to find my age, so I'm going to take August's age and substitute. I'm going to choose the equation on top because, again, my goal is to get V by itself. Notice that equation already has V by itself. So I'm going to replace A, August's age, with 24. 24 plus 2 should be my age, which means that I am 26 years old. Yay! Quarter life crisis time. And last but not least, let's listen to some music. A streaming service by the name of Schmapple Music allows listeners to purchase both individual songs and full albums from their favorite artists. One listener buys 6 songs and 2 albums, spending a total of $16. Another downloads 5 albums and 15 songs, spending $40 in the process. What are the costs of one album and one song? So let's start by defining our variables. We want to know the costs of one album and one song. So I'm going to choose A to represent the cost of an album. And then for song, S might be confused with 5, so I'm just going to pick something innocuous. I'll say something like X. I'll say X is going to represent the cost of one song. Of course, both of these would be in dollars, but that's kind of trivial. Now, I'm going to set up my system. Here's a classic cost problem. I know that my first case, I have a listener who gets 6 songs and 2 albums. They spend $16 in total. So if I take my 6 songs times the number of dollars per song, and I add that to my 2 albums times the number of dollars per album, that should get me to a total of $16. And by the same logic, I've got another person who's got 5 albums and 15 songs, and they spend $40 in the process. So same idea. I've got 5 albums. So if I take 5 times the cost per album, and I add 15 times the cost per song, that should get me to 40. From here, I could do either substitution or elimination. I'm going to choose personally substitution because if you notice, look at the top equation, for example, 6, 2, and 16. All of these are divisible by 2. So I'm going to take 6x plus 2a equals 16. I'm going to choose to get a by itself. So let me subtract 6x from both sides. That tells me that 2a is equal to 16 minus 6x. Dividing both sides by 2 to isolate our variable a, I can now find that a is equal to 8 minus 3x. From here, now that I know a is equal to 8 minus 3x, every time I see a in the bottom equation, I can substitute. So I now have 5 times a, which we've established is 8 minus 3x, plus 15x is equal to 40. From here, let me start by doing some distributive property. So I've got 40 minus 15x plus 15x equals 40. Interesting, negative 15 and positive 15, these go away. 40 is equal to 40. So this is a true statement. This system happens to have infinite solutions. When I have infinite solutions, that means that my lines overlap. They are exactly the same. Any combination, right, or any point that I can find on one line would be the same as the point on the other line. What that tells me then, in the context of this problem, I have infinitely many correct answers. In context here, what that tells me is that I do not have enough information to conclusively say what the price of one song or one album is. I have infinitely many possible correct options. Lovely. Congratulations, you've made it to the end of Unit 5. I will see you in Unit 6. Take care, be well, do something nice for yourself, do something nice for somebody else, and I'll see you when I see you. Goodbye.